One thing you should be aware of with regards to malware is how it is analyzed. Actually doing the analysis is a bit beyond the scope of of actual incident response because you're kind of there and in the moment. But there are some aspects where it is convenient to do a little bit of analysis right then because you don't know exactly what this particular piece of malware is doing and you need to look at it and figure that out. So there is several different methods that are typically used, a couple of different methods that are typically used to analyze malware. First off, we have what's called dynamic analysis. And one of the ways you can do dynamic analysis is by running your piece of questionable code or whatever it is, the malware in a sandbox. So there is a site called any.run. And this is one place where you can basically upload any old software you want, and it will it'll execute that software. It'll start up a little sandbox environment. It'll execute that software and kind of keep track of everything that's happening, so you can see what's going on with this particular piece of malware. So let me look at a couple of examples here that I just saw. So I guess one thing when you do upload a piece of code to any.run, it is if you do a free version of it, it does make it publicly available. So anyone that wants to can go and see, including the person who authored the malware. They might be interested in looking out to see if anyone has spotted them, because then they'll know that they're caught, and well, they should ramp up their efforts because they're about to be expunged or whatever. But you can see there are a bunch of different public submissions here. This is all from just recently in the last couple of minutes. People uploading various pieces of software and seeing if it's malware. So you can see some of these, they're marked as having some malicious activity. This one has suspicious. This one is no threats detected. I found a couple earlier. When it's actually run, it does spin up a little Windows environment here. And generally, it'll keep it going for a minute unless you tell it to run longer. This particular piece of malware is called Locky Exe. And the reason it is detected as a piece of malware and not just normal software, well, we can go look at the indicators of compromise here. Various IOCs, you can see it made some connections out. These are marked as malicious IP addresses, malicious HTTP. Well, yeah, IP addresses, I guess. That one you might not know exactly what's going on. Let's look at the actual executable. There's some process details down here. Well, I guess let's actually click on more info so we can see a little bit more info here. It is definitely flagged as malicious, and specifically, it spells it out in a little more detail in here. It connects to a CNC server. I've been calling it a C2 server, whatever, command and control server. Locky, and it looks like another piece of malware called Neckers was also detected. It sounds like this was probably a dropper or a downloader. Let's see. You can look through here. It looks like there were some registry changes that were made. I mean, I don't think any of those look particularly damning, but you can see the specific HTTP requests that were made out and, kind of what happened with them. Let's see, any other connections that are made. There are some network threats. There's the all the various modules that are actually pulled upon. So you can kind of see what, crypt base, that's, whatever. That's probably encryption. But you can kind of get a sense just by looking through here. You might be able to start seeing what processes it's using, and that might tell you something about what it's doing. But that's kind of guessing. Let's see, what else can you find in here? Oh, you can look at, there is actually in general on, for these, there's a link to Virustotal. If you click on that, you can actually see how it's classified by a bunch of different antivirus providers. This one is actually marked as a virus, as malicious, I should say, by 64 out of 69 of these different companies. Or you can see AVG marked it as a Trojan. whatever. Fortinet marked it as w32/cryptor.er.jk, whatever. You can see there it's kind of hard to tell exactly what's, but in general, it does look like this is some sort of Trojan, some sort of ransomware. Yeah. In any case, I have another example prepared here. Let's close that. This one was new bank details on your Star Trek invoice.eml. So this one, you can see this actually does show a little bit. The environment is interactive when you first upload the piece of software, and you can see the person is interacting with it. There are periodic screenshots taken just to document the process, basically. But it also keeps track of what processes are run. So sometimes you see a piece of malware might spawn PowerShell and then run a bunch of stuff from PowerShell, or in this case, it looks like Outlook Express or Outlook.exe is run. And there are various indicators. I click more info here. We can get more information on this. It looks like from Outlook, it does start Internet Explorer, which by itself isn't that bad. Puts files in the user directory, reads the computer name, whatever, that sort of stuff. This one, I'm not seeing anything right off the bat that is, that's a big red flag. I'm not sure why this one is marked malicious personally, but the point is you can kind of look through here and get an idea of what it's doing, what this piece of software is doing. One thing that you should be aware of is that some malware actually can detect that it is being run in a sandbox environment like this, and they might just deactivate. So this one, it might see, oh, I'm being run on any.run. I'm not going to do anything out of the ordinary. I'm just going to appear to be a normal program or something like that. There are some pieces of some viruses that will only that if they detect they're being run in a virtual environment, any virtual environment, they might not run. So something to be aware of when you're examining, doing some dynamic analysis. Another form of dynamic analysis would be, so that's kind of doing a more automated process. If you wanted to get more manual into this, you could use a debugger. This one is GDB. It's the GNU debugger. It does a bunch of different, it can do a bunch of different languages. Basically, most of the time when you have software, you don't have access to the source code. And you just have a raw, you just have a executable file, portable executable file. And it might look something like this. So this one right here, this is the actual file that I have loaded here. This is just, actually, it's just a really small C program that I compiled. But you can see this is what what it ends up looking like. Let me show you the source code here. You can see the source code. I include standard input output. I just have a little function here that returns length, width times height, and I call that function. So it's a really basic, if I run it here, you can see it says hello world. And since this particular function is called on 3 times 5, it prints out 15. So it's, like I said, it's really basic. But even something this basic, if you start looking at the compiled code, it can be really kind of difficult to tell what's going on. So one thing you can do, this is getting more into the, well, yeah, I'll get back. I'll come back to that. So what we can do is run it in a debugger. Now you would want to do this in a virtual environment because conceivably you're running a virus here. But the nice thing about running in a debugger is that you can kind of tell it to go one step at a time, to just do one command at a time. And this, the way I have this set up, I'm using, so it's not just GDB, it also has something called Jeff installed, that it's GEF. It provides a lot of, provides all of the registers. You can see what values are in all the registers. It shows you what the various lines of source code, or no, sorry, this is the actual, what is that, the heap? Yeah. This is the actual code. So currently I told it to set a breakpoint when it starts main. There's a bunch of stuff that's initialized when a program runs. So I set a breakpoint at main, and you can see it's right here. It's at the beginning of main. And this actually will kind of analyze the particular values, the various bytecodes, well, not bytecode, but whatever. It'll analyze the machine code and give you the appropriate assembly. So you're not going to be able to get you're not going to be able to get it back to C or C++ or something like that with just debugger. But you can at least see the assembly language. And if you're familiar with assembly, then you can kind of get a sense for what's going on. All right, so I think this is just kind of cool. So I'm going to showcase it a little bit. S to take a step. So whenever I hit enter here, it's going to take another step. And you can actually see up here the registers. You can see exactly what registers change on each given step. So that last step, all of these registers changed values. Here, this looks like it's a memory location to this pointer to this string. Yeah. If that doesn't make any sense to you, don't worry about it. Like I said, this is not something that you, as an incident response person, you would likely do right at the time. I just feel like it's something that you should see. Do a couple more steps here, and you can see it's just running that various assembly language. So, all right. Let's see. That would be so that's using GDB with Jeff, GEF, to basically make it nicer looking. If you're in Windows, I'm familiar with an immunity debugger is what it's called. It looks different than this. It's more graphical, but it does the exact same thing. It'll show you what the various memory locations, the registers, what code is about to be run, and so on. The nice thing about the immunity debugger is that it actually allows you to kind of inject Python script into the code. So that can be helpful in various circumstances. So this is all kind of dynamic analysis. That is examining the code as it's running. Of course, if you have access to the source code, you can just do source code analysis. So if it's written in Python, for instance, it wouldn't be compiled. And so you could just read the Python. Or if it's just a bash script, or I don't know, a Visual Basic script or something like that, you can just read what it says right there. So kind of reading through that and getting a sense of what it's doing. That one actually you do in some of the incident response labs. We did it last week. Or whatever, lab 1. Yeah, if you have the source code, you can analyze that. Again, oftentimes you're not going to have access to the source code because something might be compiled already. So there are some utilities that are useful. If you want to just tell any information, so that I'm in Linux here. If you want to tell any information about a particular file, the file utility actually can do this. So file a.out, this will look at it'll look at the file. Let's see, this one begins with the bytes 7F4V, whatever, you can read it, 7F45 4C 46. That's .elf. That's a executable. Yeah, it's an ELF file. It's an executable file, portable executable. So you can see this file essentially can look at that file. And this file utility examines the file and can tell you a little bit about that file sometimes. Let me try this on something else. What happens if I say file test.c? Okay, it notices that it is C source code and that it's ASCII text. This is, by no means is it going to be a 100% accurate, but it can be quite accurate. File test.java. That notices that, it calls that C source code also. Okay, well, there you go. It's not always perfectly accurate. test.java. You can see that's clearly not C source code. That's Java source code, whatever. So that's the file utility. We can also sometimes it's useful to use strings. Strings will go through a file and it'll look for any sequence of ASCII characters that's a certain length or more. So when I run strings on my a.out, that is the actual executable, it gets all sorts of different things. So you can see it actually pulled out puts and printf. We have hello world. That's the actual string that ends up getting printed out. Oftentimes, if there is an IP address that's kind of compiled into the code, this might be able to help you find those IP addresses, or you might just be able to search through here. And if there's the typical tagline from WannaCry, or if it actually says like WannaCry in strings, you can be like, well, okay, well that's obviously not good. So you can kind of look through strings. It is unfortunately kind of hit or miss as far as what you can find, because this is a very small executable file that I compiled here. And it has already quite a few strings. If you do something that has any size, any significantly sized program, there will be a lot more here. So you're going to have to use grep to filter things out, or you're going to have to figure out some way to filter it. Let's see what else is next. You can actually take I showed you a little bit of GDB, the GNU debugger. You can actually take that a step further, and you can use something like Ghidra. Ghidra is here it is. So Ghidra will basically read in that compiled file, and it'll show you the assembly language, So I select, I had to do some analysis already. Then you say, come over here and say, open up main. And this brings me to the beginning of main. And it does show you the assembly, just like the debugger does, but it goes one step further and it actually tries to put it into C. Tries to figure out what the equivalent C would be. This is a lot more human readable. You can see puts hello world. It looks like it calls a function called compute area, which you saw the source code, so it's actually fairly accurate with the arguments 3 and 5. Then it prints something, and then it returns. So if you can, sometimes using something like Ghidra, other options of reverse engineering this code would be like IDA Pro, IDA Free. I don't know, there's other reverse engineering software out there. Let's see. So that just gives you a little bit of an idea of some of the things you can do to analyze some malware, malware analysis. If you are interested in that, there's definitely a lot of opportunities in examining malware, but this is as far as I'm going to get in this course.